we come to another concept called couple. If you want to know the Chinese, it is this one. Now, and we begin with this one. We add a force B here, FB here. So if we add a force FB, it will lead to and the center of mass is O. Center of mass is O here. So of course we have RB here. Right? It's okay. Let me put O here, not the other side. Oh, here. Let's begin with having a force at B. We call it FB, and its moment with respect to point O is RB cross FB, right? Now, let's take a look at this force. It will lead to both rotation and translation. Because summation F is not equal to 0, right? If we have first, you can write it down first. Now, and we will lead to both rotation. For example, if we have a rigid body here, and we put a force somewhere here, right? It will both rotate, right? It will, because the center of mass is here, and we will rotate. We have rotation, and because if we add a single force, if we add only one force here, if we have one force here, it will lead to the whole rigid body to move to the right, right? Because summation F is not equal to 0, because we have only one force here. So of course we have F equals to MA and this fix. Now we have only one force going this way. How about doing this? Let's do this. We add another force here. We have FA here. And of course, I do not draw it very accurately. Let's do it with so. This MA, and we set FA is equal to FB, and FA and FB are parallel to each other. It's okay. They are parallel. So if we have FA plus FB so is the resultant force equal to 0? If we have FA plus, so a rigid body experiences has two forces, one is FA and one is FB. So is summation F equal to 0? Seems yes, because this one to the right and this one to the left, and the magnitude of the two are the same. So summation F equal to 0. So no translation. But is there rotation? It has rotation because the two forces are going. One is above and one is below the point O, right? Let me write it here, and I can add other things in the middle. So, I hope, let's have a look. If we have one force to the right on the top and one force in the bottom to the left, and of course we will have rotation, right? If we have this one and they have this one, then it will rotate. But because summation F is equal to 0, there is no translation. It's okay. Now, we want to calculate the moments about O. In this case, we want to calculate the moments of FA plus FB about points O. I think you can get this. You can get the first row. You can get the first line, right? I think you'll get the first line. Next, we have because we know FB is the magnitude of FB is equal to the magnitude of FA, but they are in opposite direction. So we can we write it like this? I think we can. And so FB is equal to negative of FA. So we can write like this. And the next step is of course, both of them has FA here, and so we will write it like this. Or we can say both of them involve FA. So and therefore we can write it like this. Now, and of course, RA minus RB is what is RA minus RB? RA minus RB is this one. Right? Which is RA with respect to B. Am I doing it correct? Now is that have I explained it clearly enough that we are calculating the moment of FA plus FB about 0.0, we have this one, and then because FA and FB are opposite to each other, so one of them is changed to FA. FB changed to FA, and then we group it like this, and we'll get here. Take a look here. Let's take a look. And we have RA with respect to B is 0.0. Do we have 0.0 here? Because RA with respect to B is this green vector in green, so is 0.0 involved here? Seems not. Okay. So this RA with respect to B is independent of O. Is that okay? We are dealing with a pair of forces. We have two forces, and they're going this way. In this case, we can the moment of FA plus FB in this case is independent of point O or any other reference point. Point O can be here, point O can be point D here, point E here, point F here. That you will get the same result because the moment arm in this problem is going only from B to A. Therefore, in this case, we are only writing the moment vector M, and we don't need to mark the point of reference. We don't need to mark the point of reference. Is that okay? So we have a special kind of we have two forces, and they have special relationship between the FA and FB. We have a name given to them. The name is called couple. So the definition is here. So we have two forces, FA and FB, and they have the same magnitude, and their lines of actions are parallel, and they are opposite to each other. They are one going to the right and one going to the left. One going to the right and one going to the left, and these two forces form a couple. So a couple has two forces, okay? It's okay. Now, and, you want to do one more thing here. And I go to the lower half of the page, and I go to the lower half of the page, but you can stay, you can watch, you can read the whole page. Let me see. Okay, I think I should make it again. Oops. Okay. Now, and we have this at the top of the page because I can't show it to show whole page here. And for this one, of course, we have just now we have determined the moments is equal to A with respect to B, which is from B to A, cross FA, right? This is the moment of this couple. And our A with respect to B can be divided into two parts. One part is here, and one part is here. I should use it. Let me use another. Let me use another color. I think we can write it. We can do it like this, right? This one is R parallel to FA or FB, and this one is R perpendicular to FA and FB. Is it clear? So for our moment R A with respect to B, we can divide it into two parts. One is parallel to the forces, and one is perpendicular to the forces. Right? Now, and by mathematics, and of course we can do this. And because these two are parallel to each other, sine theta equal to 0, so this one is equal to 0. So what do we have here? We only have the moments of this couple is calculated by the distance between the distance between the parallel lines cross the force vector. Is it okay? We only need the perpendicular distance between the two parallel lines, and then we do the cross product with FB or FA. I mean, this way. Sorry, this way and this way. If we want to get the magnitude, M is equal to D dot F, and D is of course the distance between these two parallel lines. This is the equation 3.46 on page 119. Okay. So after these 2 weeks, I think we have gone through much with moments, and I think let's have a quick look because next Thursday the quiz will go to we will cover until here. and from chapter 3, and then from the beginning of chapter 3 to here. Okay. Now, and before do the revision, let's have a quick look of the different things we learned in the past 2 or 3 weeks. So I'll go back to that page in a minute. We go to page 30. We go to page 30. I think 31. Now, we have learned these 3 things. We have learned all these 3 things in the past 2 or 3 weeks, and they have different meanings. They have different meanings. Let's have a look. For MA, that it means moment about a point A. I think we have moment about point A. And for MAB, what is MAB? If MA is moment about a point A, and what is MAB? Moment about a line AB. And M without any symbols is moment about moment of a couple. Is there are 2 forces, remember? Oh, sorry. I think if you want to make it clearer, and moment of a force about line AB. Yeah, sorry. And this one is, of course, moment of a force about a point A. It's okay. So for the first one and the second one, they are moments of a single force. But for the right hand side one, that we are talking about the moment of 2 forces together. And here, and for MA, of course, it is equal to R cross F, and MAB is equal to R cross F times lambda AB. This is with dot product there. And for the last case, M is equal to R B with respect to A cross F. If we have A and B here, and F is here, So we have learned quite a lot of things in the past 2 or 3 weeks, and they have different meanings. And I will work on examples. I will work on examples on Thursday. On couple.